now. Okay, everyone, thank you very much for joining this afternoon. Today, we are very pleased to welcome Dr. Anna Lennquist from the ChemSec NGO. Dr. Lennquist is ChemSec's senior toxicologist, where she leads the SYN List project, which pushes for removal of chemicals in articles, products, and manufacturing processes. Today, she will be talking with us about how science and policymaking can be joined together better, as well as recent debates within the chemical policy space. So thank you very much for coming to speak with us today, Anna, and the floor is yours.
Thank you. Yes, I know I have quite a lot of time compared to what I used to have, so I will talk a little bit about many things, I thought. I will talk about who we are as an organization and why we do what we do and what we do, and also some learnings from having been in this field for a while, and an update of some of the constant debates and discussions in the interface of science and policy, I would say. And so I work for this organization called ChemSec, based in Sweden in Gothenburg. And this is actually all of us at a rare occasion when we all met a few weeks ago. So we are a mix of experts from toxicology, chemistry, but also communications, legal scientists, and whatever we could need. But we focus much on communication, and by bridging gaps, that means that we want to bring messages from companies and from scientists to policymakers, and get a better understanding there to get a more efficient regulation on chemicals in the end, and a better chemicals management. And I said some of this already. So we were founded also by 4 other Swedish environmental NGOs to be a sort of expert organization also for them, and also acknowledging that the chemical issue, as with climate or anything, is something that we cannot really tackle within the borders of Sweden, but we need to work on an international level. And we have worked mainly on an EU level since, I would say. So we're not very well known in Sweden at all, and that has not been our sort of target, but to work on the more EU policy level. And our goal and vision is the same as the Swedish environmental target or environmental goal, miljömål, toxic-free environments. We receive some of our funding from the Swedish government as an organizational support. There are some other organizations working on climate and fishing and other things that have the same kind of support. But the main part of our funding, we apply for different projects and for different charity funds, and also like EU funded projects and a variety of sources. So that's the same as in science, that we're sort of in a constant search for funding for what we want to do. But looking into why we work on what we do and how we see the problem of hazardous chemicals as a global issue. And sometimes we also say that we see this as an equally big problem as climate. And I think they are all interlinked, actually, also the climate change, biodiversity, chemical pollution. And if we look into the problem of hazardous chemicals, we know that chemicals in general have doubled in production only since the beginning of this century, so in the last 20 years. And what I usually believed was that the part that was hazardous of all these chemicals was the small part, and the big bulk was just sort of normal bulk chemicals. But actually, the Eurostat came with some statistics on this a few years ago, showing that in volume, 73% of the 345 million tons of chemicals that were produced in the EU were labeled for being hazardous to human health and the environment. And we also see that a growing number of chemicals are found when we look in human tissues, blood, urine, whatever, and also around the globe in environmental samples from polar bears to water and so forth. And this we have this example of Pfos, for example, when They wanted to start looking into the PFAS level of people working in PFAS plants. They could not find a clean control blood from when the production had started, but had to go back to sort of archived samples from recruits that were taken before the PFAS production. So the chemical production has really gone into every compartment of the world of the chemical pollution. And it's difficult, of course, to link this specifically to human health issues and also environmental problems, because we are so exposed to so many different things, of course. And it's difficult to say what is lifestyle and what is climate and what is chemicals. But a growing number of evidence and epidemiological studies, and also linked to what we see in controlled animal studies, can link the chemical pollution we have today to problems like cancers, reduced fertility, biodiversity loss, and more. Perhaps you've heard the term spermageddon, which has been a bit in, especially US media, following on several reports showing that fertility is quite strongly linked to endocrine disrupting chemicals that are more and more widespread, and that we have seen a significant decrease in fertility. There was a report from the WHO recently that attributed 1.6 million deaths globally to selected chemicals. So those were the ones where you can actually know it was chemicals. We also see that the chemical producing industry is the most energy consuming production sector, and it accounts for a large proportion of the world oil demand. So it's not all about aviation and transport, it's also about production of chemicals, which in turn is the result of that we are producing so much stuff, more or less, plastics and things. And also in a recent study of European citizens' perceptions, 84% said that they were worried about the impact of chemicals on their health. So it's also something that people care about, even if I would say it's much less known than, for example, climate change. So that is the reason behind why we exist, and the issue we work on from different levels. And as you saw, we have grown, but we are still a small organization of 12 people. So we cannot do much of our own, but we hope to leverage where we can and to sort of impact where we can by working together with others. So one thing we do is that we try to drive the political discussion. That means that we sit in different committees like at ECHA and the Commission, and wherever legal regulation of chemicals and implementation of regulation of chemicals is being discussed and decided. We sit there as stakeholder observers, but can also make our voice heard. And we also publish position papers and try to be concrete about the changes we want to see and have sort of concrete proposals for changes and improvements. Another important part of our work, which I will soon talk more about, is that we have much dialogue with companies and try to help them to improve their chemicals management, both by just talking about the issue as I just did, but also to provide concrete tools and guidance for how this can be done more concretely. And that's those tools I will also talk about. And more recently, we have also, or it's not so recently anymore, but the last years, we have also focused more on financial investors, especially investors that want to be sustainable and have sustainable investments, how they can include the issue of hazardous chemicals in their evaluation of companies. So that's a more recent topic. So much of what we do and what we think originates from discussions we have in this group of companies. This is a quite small group, and important for us to say is that we don't get any money from these companies, or we don't have any financial or legal ties. But it's more a discussion group. That means normally we meet once a year face-to-face and have a few calls in between in different constellations. And what these companies have in common is that they have a will to work progressively with chemicals management, and some are quite far ahead of the regulation actually in their internal policies, and others are willing to do so at least. And those are from very different sectors, as you might recognize some of them. But the issue of chemicals can still be discussed amongst them. It has also been easier sometimes, maybe because they are not competitors, and they can also learn from companies that they don't normally talk to because they're not in the same sectors, and get ideas that they can also use in their business. And one of our sort of specialties, or what we do, is that if we can bring a message from these companies to policymakers and say that actually these companies would benefit from a stricter regulation because they have already faced this and this chemical out since years, and for them it would be beneficial and a way to ease the play field for them if other companies also had to do so. So that's a message we can bring, and we can also then know if sort of the things we propose are realistic and can be done in a company, or if it's possible, if there are alternatives and so forth. So I will go into and talk a little bit more about how we work with companies and how we see that regulation drives innovation, but also the other way around. When there are solutions available, it's easier for policymakers to make decisions than when it's not. So as John also said in the beginning, I have been working with something called a SIN list almost since I started at ChemSec, which was 2011. But the SIN list was in place already in 2008. And so this is maybe our most well-known project, and which is often more well-known than as a name than ChemSec is itself. And this was something that we did early on when REACH was just in place, and sort of the idea of REACH and all the different concepts were there. And one part of REACH is to list substances of very high concern on a so-called candidate list as a first step towards a ban or a regulation through the authorization process. And when this concept of this list was in place, the companies we talked to, they asked, what substances do you think will be on the REACH candidate list? And because the candidate list is built up by the way that different member states, EU member states, propose a substance for the candidate list, and then all EU member states have to agree that this is a substance of very high concern. So it's quite a lengthy and unpredictable process, because member states propose substances for different reasons. Often it is to sort of test the system, or to see like where are the boundaries and what can we agree on. So it's not really a system to that. But with the SIN list, we could instead upfront, before there were any substances, present a number of substances and by using the same criteria as in the regulation, but by listing these substances much quicker. And that was found very helpful for the companies, because then they know what substances to keep track of, and that may be targeted by regulation. And that's also what the abbreviation SIN stands for. It stands for substituted now, even though we of course also know the second meaning of it. So it has been, lists are always popular. You know, we've seen in media, here's a list of the best wines for the summer, or the top 3 things to improve your sex life, or whatever. So this has also been our experiences, that listing stuff is powerful. And since the launch in 2008, it has grown continuously. And when we checked a few months ago, we had 40,000 users over the last year back, from 197 countries. So it's not so EU specific that you would think. The country with the most SIN list users is the US. but then it's also a lot of European countries, but also in Asia, Australia, and so forth. And how we have done is that we have updated this several times through the years. And when we do that, we have always tried to follow the discussions, because the aim of the SIN list is still to predict the development of the REACH candidate list and also to influence it. But to do that, we have needed to take part in the discussion and sort of see what's coming up and what's hot and what's needed. So the first update, main update with a focus was in 2011 when we added endocrine disrupting chemicals. And this was very powerful because at the time, this was a topic that everybody talked about. We have to do something about endocrine disrupting chemicals. Companies had this from their customers. What are you doing with endocrine disrupting chemicals? But there was no list of endocrine disrupting chemicals. There was no way to prove that you were working on them. So by contracting expert scientists in the field, we selected 22 substances where we had a lot of scientific evidence that those are endocrine disruptors. And that list, then, whatever you thought of it, it was at least something to sort of refer to and come back to, that companies could act upon and that policymakers could discuss. That sort of, okay, so these are the chemicals and what should we do about them? 2014, we had another focus, which was what we call regrettable substitution. And that means that it's been very common that you replace one hazardous chemical with a very similar one. So for example, bisphenol A has been replaced with bisphenol S and bisphenol F, and brominated flame retardants have been also replaced with very similar ones. So in this update, we added a number of those bad substitutes, so to say, but we also had evidence. So there were also endocrine disrupting chemicals and PBTs. And in 2019, 2 years ago now, we added a new category where criteria are now being discussed more in detail. And this is the category of chemicals called PMTs or VPVMs. So that's an equivalent to persistent bioaccumulative and toxic chemicals, but instead of bioaccumulative, those are very water soluble and thereby very mobile. And that's what the M stands for, mobile, is so that they are spread quickly around the globe. And the main problem with them is that they are very difficult to remove in sewage treatment plants and also in natural filtration systems, because they don't stuck to particles basically, but they just remain. And so that has been acknowledged as a problem, that it's very difficult for drinking water safety if we don't target those chemicals. So that's what we did by then. But sort of the other side of the coin, the question you always get when you say don't use these chemicals is, of course, well, so what should we do? What should we do instead? What should we use instead? And therefore we launched the Marketplace project. And this is a dating site, we called it in the beginning, because it's a place where producers of safer alternatives to chemicals on the SIN list can advertise their alternatives. And companies that want to use safer alternatives can go in there and search for them and browse what's there, and also advertise for alternatives if they don't find what they are looking for. And the information on the marketplace is quite brief. So if you want to use something, you have to take contact and continue the discussion elsewhere. That's the analogy of with a dating site more than a marketplace in one way. And you don't buy any chemicals there, but you get to see like a shopping window, what's available and who to ask and how to move forward. And that has been that's a really appreciated concept. It's still difficult to get companies advertising because I think it needs to be often alternatives are very specific and it's difficult to show that it's actually helping to advertise here. For some it has, but it's not always that you find a customer. But this is still the idea of a marketplace for safer alternatives has been asked for a very long time and still is. And this is still like the only the only place where you can find something like this. So we will keep it, and we will continue to work on it, but it's more difficult to host than the SIN list, for example. In that sense, it doesn't run itself. And as I said, we have also been working with investors, and last year we launched for the first time something we called ChemScore. And here we looked into chemical producing companies from 4 different aspects of how they perform in terms of hazardous chemicals. So it's both what chemicals on the SIN list do they produce, but it's also, are there phase out plans? Do they produce alternatives? And have they been involved in many scandals? For example, now there are several companies involved in cleaning up PFAS, for example, which is a huge cost and also a financial risk then for investors. So they need that type of information. And then we have scored them according to a system. And now we are doing that again. It will be probably launched before Christmas, a new round of scoring. And over this is quite a lot of work, where we also discussed with the all companies scored, and they have the possibility to add further information to us to help fine tune the scoring. But our initial assessment builds on everything that is officially available on their website. And the last sort of tool or company thing I will talk about is our Pfos movement. So here we gather companies that say that they support a stricter regulation of PFAS chemicals, and that they will also work internally on phasing them out. And this is a very simple project in that sense. It's only to sort of sign on that you support those things. But it's very useful, again, for us when discussing. There is a big discussion now about a PFAS restriction of all PFAS in all uses to start with, and then it will probably be narrowed down. But to be able to show that companies also support this restriction is very important. And some of those have actually also seen it as a marketing advantage. I've seen now in the pharmacies in Sweden, and that some of those, I think Idun Minerals, makeup cosmetic producer, they have actually added our No to PFAS logo on their commercial thing. So they see it as also a competitive advantage to show that they don't have PFAS. So now I thought I would like to present sort of from my perspective or my experience in this working field. What are the constant discussions and debates that keep coming up and the different views there? Because it's a special field where science and policy meet, where scientific findings will be regulation. And it's also a high interest from stakeholders like environmental organizations, but also definitely chemical industry. Yeah, you're welcome to ask questions about this afterwards, of course. So the first issue I would like to bring up is that there is a constant discussion about science and what is sound science. Sound science has become, in my mind, a bit of a bad word because it often means industry-funded science that is called sound science in those debates. And there is the discussion about what science we should use as grounds for decision making, especially in terms then of assessment of chemicals. And there has been, it's changing, thankfully, but it's going slowly. There has been the idea that science that has been performed by industry using good laboratory practice labs and specific OECD test guidelines are the tests to look for. And of course, that is great, because then you know exactly what you have and it's done according to a standard method and so forth. But there is also the downside of that is that all kinds of independent academic data that is done differently, because you're in a constant scientific process and you're using your normal lab, and all those normal peer-reviewed studies that are getting out in different journals have not been seen as high quality, because they have not been done according to a OECD standard study. And there is a constant debate for every chemical that is being discussed, sort of what is the high quality studies and what data can we really count on. And I see that that has changed, thankfully, over the years, but that's still the case, that those standard studies are seen as high quality and sound science, and the other ones are seen as less important. And there has been some initiatives to sort of try to change that, or try to make that better. And there are some scientists that have proposed different ways that makes scientific publications more easily accessible to regulators. Like one such thing that I never did when I was a PhD was to add the CAS numbers of the chemical I studied. I just added the name, and thereby it wouldn't be found, I think, today. And also, I lose the name now. There's this methodology to evaluate a huge number of studies. It will come to me. But takes into account different parameters also to evaluate the quality if you don't have a standard study. Comes something in the chat here, maybe. Yeah, not meta-analysis, but that is also a good thing. Systematic review was the word I was looking for, thank you. Which really is helpful. It has its downside as well, but it's helpful for policymakers to understand better the quality. Because I've also understand that the recent years it has been a lot of more publication without peer review, so open access, and also not paywalls. And I think it's, well, I don't have a strong opinion there, but I think it makes sense that those journals don't earn very much money. But that also makes policymakers even more uncertain about the quality if something is published without peer review and without open access, and confuses things a bit more. But in general, I think when you are a scientist, of course, you think that the data you publish will be picked up and used, but it has not been automatically so. And I hope it will be, it's improving, because I think it's just a huge waste of not using scientific peer review data more in decision making. And the next thing I wanted to mention was this, how to deal with uncertainty. And this is also a little bit in this field of science and policy, because as a scientist, when you finish up a publication, almost every publication ends with what you would need to study next to be more certain about your findings. And that also makes it very difficult for policymakers to take a decision. And when you study hazardous properties of a chemical, for example, there will always be uncertainties about mechanisms and links and so forth. And the tendency has been that when there is uncertainties, the authorities tend to ask for more data to be provided and more tests to be done by industry. And then industry don't want that because it's very expensive, and they overrule, and it goes to a board of appeal, and it takes just very much time. And this has been really a roadblock in the process of regulating chemicals. So instead of acting on the data you have, you tend to focus on what the data you don't have, and which would be nice to add to the picture. And that is, we usually call a paralysis by analysis, that you don't dare to do anything. But the safest way out, I always feel like it's to ask for more data. But there is actually room in chemicals regulation to use the so-called precautionary principle. And in my opinion, this is exactly why you need a precautionary principle, because you can almost never have all the data at hand, but you still need to act. But that is a constant battle. When is enough data enough to take a decision? And their opinions differ, of course. And there I also wanted to come into a little bit a debate that is coming back all the time, which is animal testing. There is a strong political will to reduce animal testing, which I think is good and which we support, of course. But we don't see that it's possible for all hazardous endpoints to provide information without animal testing. But it's very popular now to say no to animal testing. And I think this is a bit of a provocative title to me as a toxicologist, to say that we use science, not animals. I think you can use science and animals, actually. But it is an important development, and this is where we are going and where we need to go to develop more non-animal tests and to be more certain about the outcomes there. And from our perspective, I also see that we can do a lot already to reduce animal testing, where what I just said, this paralysis by analysis, is the key issue. That if we can act earlier and don't always ask for more data, that's a very good reason, or a very good way to reduce unnecessary animal testing, as is to make better use of the academic studies that are available. We can also do much more with read across and grouping of chemicals, look at similar chemicals and draw conclusions from that. And I think also something that I will come into a later slide is also to be able to regulate more based on the intrinsic hazardous properties and not having to do costly risk assessments, which may also need animals to perform. And then, of course, we need to continue scientific development on non-animal methods. Another thing that always happens is that when a new regulation is being discussed, there is always an impact assessment. And that impact assessment is a study of how this regulation will impact. And it has been very much focused on how it will negatively impact industry in terms of money, more or less, but also how this can impact society. If, for example, a factory would need to shut down because the chemical is being banned, and lost jobs would be lost. And you try to calculate what that scientific or that the societal impact of that, the socioeconomic assessment. And this is, of course, a tricky calculation that is being done in scientific committees. So how can you value the protection of health and the environment versus, for example, loss of jobs or costs for industry? And that balance is always tricky. And it's easy for industry to show numbers and say that this will cost this much. It's much more difficult to value health and environment, of course. And when it's like now, I'm sitting in a committee discussing the criteria for PMT chemicals. And when we discuss the criteria for mobility, they are always showing, like, if we put it here, this will mean that this high number of chemicals will be targeted. If we put it here, it will mean that this number. And somehow the debate comes from the scientific part to targeting a reasonable number of chemicals. And that is always also a balance. I think we need to know that, of course, what impact regulation will have, but it needs to be balanced between sort of science and impact, of course. And also, when we discuss this, industry is not one thing. Companies are very different. There are the companies producing something hazardous that might be targeted by regulation and that are worried. but that are also the ones that produce alternatives or have alternative technologies that would benefit from a regulation. And those are more rarely heard. And that's also something that we try to focus on, to get also those voices into the discussion. What would it mean for, it's very difficult for an alternative provider to have all that cost of innovation and having set up that have a solution, which is often more expensive in the beginning before things get up at scale. And they are maybe prepared for a ban that have been discussed for a long time. But if that ban doesn't come, they don't get the market and they lose a lot. So it's important to take all parts of industry into account into such an impact assessment or calculation. And then there is this, we always end up here, the hazard versus risk discussion. And now I cut this picture a bit ugly. But it's always also, I can be a bit frustrated that hazard risk is often explained with silly cartoons and quite childish explanations. Like a lion is a hazard, but if you have it in a cage, it doesn't pose a risk, and that can be transferred to hazardous chemicals. And it's always this debate if you should ban something based on the intrinsic hazardous properties or based on it actually causing a risk. And as REACH is set up, we have both systems with authorization and restriction. So in the authorization process, we have substances of very high concern that are identified based on criteria that should be the really, really most hazardous substances. And there the understanding is that those should be phased out unless there is an authorization to continue use for a specific purpose. And I think that's a really effective way to do when we're talking about the most hazardous chemicals, that you should replace them wherever possible. And if it's not possible and you can prove that there is a low risk and so forth, then you can get a permit to continue use it for a while, but there should also be a substitution plan. Risk assessment, which is under restriction, is the opposite. Here the burden of proof is on authorities to prove that a hazardous chemical actually causes a risk now in real life, in the environment or for health. And there you can base a restriction on a specific use of a specific chemical. So it's much more narrow in that scope. And here again comes all the time the claims of sound science, saying that risk assessment is more scientific. And I think that's wrong to say. Hazard assessment is also science. This is different policy measures in one way, or what type of information you want to regulate. And I think the problem with risk management or with using a risk assessment as a base for regulation is that it's almost impossible to encounter for all situations where the chemical will be used, for example. So often you regulate based on intended use, like if you have phthalates in an electronic cable, it can be okay to sell that if you say that it's for outdoor use, because then they have estimated that the risk of using that indoors is too high, but people normally don't know that. I would think that it was just a better quality if an electronic cable could be used outdoors, and I wouldn't hesitate to use it indoors. So there are all these kinds of different uncertainties built into a risk assessment, which makes it less protective, in my opinion. Then, of course, there can be less hazardous substances where you might have a risk in a specific exposure, but I think that's a different case. And when we talk about those substances of very high concern and the most hazardous chemicals, the most efficient regulation is to base that on the intrinsic hazardous properties, and then use risk assessment for specific uses if you really have no alternatives where it's really necessary to use the chemical in that use. And we did actually a bit of a silly campaign on that a little bit, where we made a fake website for a fake consultant, number one in greenwashing. So where we try to illustrate all these different arguments that are used to continue using hazardous chemicals and selling hazardous chemicals, and all those different tricks to sort of confuse policymakers about what this is really about. And here we also have a film which is quite funny. I don't think I managed to show this through Zoom, but there's a link there and you can watch it afterwards, where we try to illustrate how those arguments can be played out. So the final thing I wanted to just mention that is happening right now and that is being discussed a lot is the EU chemical strategy for sustainability. And with the new commission, there was presented a Green Deal, which I'm certain that you've heard about from the EU, which have a lot of different strategies under it, and the chemical strategy is one of them. And it was launched a year back from now. And we wrote on Twitter that it made our eyes tears and gave us goosebumps because actually it has so many things in there that we have been fighting for a long time and that we think are important for efficient chemicals regulation. And it was supported by the Parliament and the Council, and there is an action plan for how to implement this in the coming years. And it actually means a difference in all areas of chemicals regulation in the EU. So all parts of it will really be revised and looked upon again, and a lot of different important elements are being introduced. So things will happen quite soon and quite quickly compared to how chemical policy normally works. So it will be definitely exciting years to come, where everything is sort of being up for discussion again and then being put into place. So we are very happy about this. We think it's very ambitious, actually a bit worried how they will manage in the short time span that it has. But it's a good start to at least work towards those targets. And it covers a lot of key areas. So for example, the hazard risk, saying that we should focus on intrinsic hazardous properties as much as possible and use hazardous chemicals only for essential uses, which is something that needs to be defined. And that there should be a focus on producing safe and sustainable chemicals only in the future. It also says that it will reward frontrunner companies and that it will help by different financial means to transform industry into a more sustainable direction and focus on innovation and substitution. And it also states clearly that hazardous chemicals is a main problem and it's urgent to do something concrete about it. So the years to come are so many discussions and expert committees and groups, because even if the chemical strategy, in our opinion, has great promises and looks great, the devil is in the detail when we come down to defining all of those things in there. So for example, when we say safe and sustainable chemicals, what is that? Can we agree on a definition? When we say that the hazardous chemicals should only be used in essential uses, what is an essential use? It should be essential for the functioning of society. That can be almost anything. So that is something that is being discussed. It also says that there will be a high-level roundtable. We are part of that, where both industry and environmental organizations and scientists and a lot of different stakeholders have their say into this process. But it's also said that even if the ambition for the regulation is being higher, it should be simplified regulation and a lesser burden on industry. So that's also quite tricky to balance. And there will be, of course, all these impact assessment, whatever change is proposed, there will be these assessments on the consequences of this for industry and for society, and how to do them in a balanced way is important, of course. There will also be a revision of REACH, which is, is always a bit scary when you open something up. That there are parts in REACH which we really appreciate and are important and have seen deliver, and that we don't want to be lost, of course, during this process. Now I talked for a really long time, much longer than I thought. Thanks for listening. We have a lot of information on our website. We're active in different social media channels, so you're very welcome to follow us or to look things up. And now I'm also happy to answer questions.
Great, thank you very much, Anna. You have such an interesting vantage point from like industry and policy and academia, and that was just really interesting to see, yeah, your viewpoint of everything.
Thank you.
Questions, please either just jump in or you can raise your hand or put them in the chat. I do have, or sorry, Matt, you go ahead.
Anna, I want to ask you an unfair question, because one thing when you start to make lists, people will look at the lists and ask you unfair questions. None of the companies on your list of companies gets an F. Even DuPont gets a D+. And several companies get a D, actually. I wonder what they have to have done to be worse than DuPont when scandals are considered. But what would a company have to do to earn an F? Is that on your scale even?
Oh, I am not working on that project specifically. I don't think it's on the scale. I think the D is the lowest one.
Okay.
But I cannot say exactly how to get worse than DuPont. But there is criteria.
I guess you could be Chemours, right? You could be the DuPont spinoff.
I mean, it's also always this that they merge and they divide the companies, so it gets a bit different from year to year. I'm sorry, I cannot give you more answer right now.
No, that's nice. It might even help to just say that D is the lowest score possible.
Yeah, okay.
I want to ask another question if no one else. Oh, okay. Go ahead, Anna. Yeah.
Okay. Okay. Thanks for this great talk, Anna. It's really interesting to hear. And I wonder, in all these committees that you sit on and discussions, including industry, have you experienced a more diversified voice from industry? Industry, as you say, it's not one. It's those that want more stricter regulation on chemicals, and then we have DuPont and all the others, perhaps, that rather go in the other direction and sound science and impact assessment and all this. And do you feel that that this has been improved and been more diversified over the years?
A little bit, I would say. I think the problem is where we sit in those committees, it's always the company that is about to be affected by a ban that sends their representatives and fight against the ban, of course. But in general, when talking to like the companies in our business group and others, I also feel that they are, I think one thing that has changed is that also what we call downstream users of chemicals, which is chemicals or companies using chemicals, but not mainly producing them, have realized the need to have more expertise also on their end. Earlier, they always trusted chemical industry to be the experts and sort of would buy whatever they gave them. And I think that has been a big difference, that many companies are scaling up their sustainability departments and see the need to have the expertise in-house to be able to ask the right questions back and to put more demands. And that also changes the chemical industry, of course, when the companies ask for other information. And one thing is also, it's often the same companies that produce the bad chemicals and the good ones, let's say. I don't like to say bad and good, but because if you are producing a hazardous chemical likely to face a ban, of course you try to invent an alternative to keep your market. So those are quite big companies with different departments and different people in there. So you find a bit of everything. And what we want to do is to sort of, somebody said that there's a certain balance, I think 80-20 or something, that when the demand for the alternatives goes over a specific threshold, you would it would be reasonable to shift the production. And we sort of want to try to push that point with the marketplace and companies asking questions and with regulation going a little bit quicker. Because I think that many of those companies sort of are prepared and have something up their sleeves, but it's probably a bit more expensive to produce right now, and it's not so up and running as the old one where you know exactly how it works. So, but then there's also a difference between chemical companies, of course. We have worked with the DSM, for example, where representatives can be really, really outspoken and have high ambitions and sort of give strong messages. So it's a big variety. As I say, industry is not one. It's all the scale.
Thanks.
Here's something in the chat. You showed a group picture in the beginning. Is it correct to assume that all the different projects you presented were done by only 13 people? Can you tell us the different backgrounds you need in the group? Well, we have never been so many as we are now, but we do contract a lot of consultants for our different projects. So for example, for the SIN list, we have contracted scientific groups to do the background studies of the substances we bring on the SIN list. And then we have consultants for making all websites and films and what we make in terms of consultations. We have had consultants making the background information also for the scoring of the chemical companies. So yes and no, but I think we are a good bang for the bucks, so to say. We are producing quite a lot for being so small, and I think that's much about finding the spots where we can make the most difference and skip projects and expert groups where we don't think it really matters so much if we sit there. We always have on our weekly meeting this huge list of things that we are invited to, and we really discuss what would be the most important and where could we have the most impact and what is sort of our part. And in terms of expertise, we are a few more scientists from chemistry and biology, but then we have more legal expertise and background from authorities. And then we have communication experts. So I'd say those are the three main categories, but none of us has exactly the same education or background. So we try to keep a diverse set of staff.
Hi, thank you very much for the presentation. I thought it was very interesting. I was wondering if you saw a change of companies, kind of a willingness to do something new or to adapt to new regulations since the Green Deal, or since now they probably have to adapt much more than before. Do they have a change in behavior?
Actually, I think that is one of our messages we try to bring, to say that, hey, look at this, it will happen a lot, you need to adapt. I'm not sure they get that message from so many other instances. So I'm a bit like, it might come a bit like a shock, or I think we need to educate companies more on that this is coming. Of course, the chemical industry is aware, but other downstream user companies are possibly not as aware. And of course, there are some ECHA is having a stakeholder day tomorrow, for example. I'm sure there will be information there. But I think so far, so little is yet defined. I think companies wait till they know exactly what they need to do.
Yeah, okay. And just another question. Companies seems very reluctant. I mean, I know we say companies and there's a lot of different ones, but they always seem very reluctant to do anything that related to change. While we could imagine that as a company, sorry, they would adapt to anything to sell more and to produce more products. how come with chemicals? Is it because it's actually very complicated for them to change something, or is it just very complicated? And is there a case study that we can show them that this company changed this chemical and now, I don't know, it's better somehow, or they have less problem? It seems like it's always such a struggle. While
yes, it's a good question, and I mean we have tried to show such examples. We would love to show that. We made a report some years ago called The Bigger Picture, where we also wanted to say that if you don't just look at the kilo price for one chemical versus another, but the full picture of substituting to a safer chemical, and you can get a better reputation, and you don't have to pay fees and so forth. So we all the time try to show the benefits. I think it's, again, very different company cultures, and that some companies are more sort of old school and fight any change. I think it is a significant cost to develop a new chemical or a new alternative when you have something that works and that is cheap to produce, and you have all the customers happy. And so I realized it is a big thing. But I think they react very differently. And it feels also, like I say, I think that some companies, they have a plan B, but they fight as long as they can all these fights help to delay any decision. So it's relatively easy to delay a decision for a couple of years and get more time to adapt. I think that's the strategy.
Thank you.
Yes.
Here is my second question. I really like your idea about regulating chemicals based on intrinsic properties rather than risk assessment. I think this is very ambitious, though, when you look at the way chemicals are regulated now, because risk assessment is sort of ingrained, and this is so good for the industry and perceived as good for innovation, that I think it will be hard to go entirely to an intrinsic or a hazard-based assessment scheme. I wonder if we could get 90% of the way there by shifting the burden of proof for chemicals that have hazardous intrinsic properties so that they are not assumed innocent. The way I understand it to work now is all chemicals are innocent until proven guilty. And you must then demonstrate through risk assessment that this chemical should be regulated, unless it's very bad from an intrinsic property point of view. So it's VPVB or VPVM. Do you think that there is any political will for shifting this somehow? So you do a screening assessment based on intrinsic properties, and if you fall into a worrisome set of intrinsic properties, then the burden of proof is shifted to the industry to have to demonstrate that it can be used safely. And I think then the uncertainty cuts the other way. Then it is up to the industry to reduce uncertainty enough to satisfy the regulator that the chemical could be used. Yes. And maybe then it goes into something like essential use. What are going to be the allowed uses where you can control emissions? This isn't really a question. This is more like an idea that I've been toying around with myself, and I want to see if you think this is a productive idea or not.
I think it's a productive idea, and I think it's in the chemical strategy.
Okay.
There they also call it generic risk assessment. Has been a sort of a new word for hazard-based, which more or less means that over a certain hazard levels, we must assume that the risk is too high. So that's sort of a generic risk assessment, or that the exposure should be zero, more or less. And so the chemical strategy really wants to change that. And also REACH in itself from the beginning was coming from no data on anything to at least that you have to provide some data in order to produce and sell a chemical. And that is relatively, the last registration deadline for chemicals were only a few years ago. So that is very new to have all that registration information. And it's only just now that authorities are going in and asking for more compliance there and realizing this very inconclusive data and asking for more but at least it's going in the direction that there should be no data, no market, and that there should be a burden of proof on producers. And I think one area where it has been concretely discussed is about grouping, so that we can say, for example, if you are to produce a bisphenol, where we know that most bisphenols have these properties, you would need to provide evidence that this specific one doesn't share the properties. That's not yet in place, but that has been a concrete proposal for how to do with this, where industry needs to prove.
Do you think that the regulators, like, do they see this to themselves, that the reason that uncertainty acts against, like, the reason that uncertainty prevents action is because the default assumption is that chemicals are innocent? Do they see this, or do they believe that they're objective and that they have no assumption at the beginning?
Who believes? I'm sorry.
The regulators or the decision makers.
Yes, I don't think they think that they are innocent. I mean,
Okay.
that's the iceberg picture in the beginning that I showed. It comes from the European Environment Agency. So it's still a figure that sort of moves around. And also this, that 73% in volume is labeled as hazardous. So I think that the issue is becoming more and more acknowledged. But then, of course, there is this huge knowledge gap. All those chemicals we have no data. But I don't think anyone thinks that they would be safe because of that.
But still, if there's no data, you don't do anything.
No, that's a problem.
Yeah.
Or at least you cannot sell or produce in the EU above 1 ton per year, as REACH looks.
Yeah. Okay, that's true.
There's
so you have to produce a minimum amount of data
as well, with about oil. Could the production of certain chemicals be kept at a threshold to ensure both environmental protection and reduce CO2 emissions? Yes, I think, I mean, there are also these initiatives with bio-based chemistry. So using, but there is always the discussion about if this is competing with food production. If you're using bio-based sources to produce chemicals from. And then there are also sources using like scrap from wood production or something. And I think that's an interesting development. What I've seen is that nobody thinks that it's possible to scale up to the same size as the petrochemical production today. My personal opinion is that I think we need to produce less things. We need to move more towards a circular economy where we repair and restore and reuse and resell things as far as possible before we recycle the materials. And then there are, I know there are things done in the chemical industry on reducing CO2 emissions and so forth. And that also has been used almost a little bit as the diverting attention from what you actually produce by showing that you have reduced CO2 emissions. So there are things happening, but I don't think people are so aware that this is an industry that is such dependent upon oil. On the other hand, I mean, this is the base industry for all other production. So it's a bit, we cannot only blame them, but we need an entire shift, just producing less things from better raw material.
I feel like this discussion can go on for a very long time, which would be fantastic. We have reached a little bit past 4 o'clock though. If there are any other pressing questions, maybe try and sneak it in now. Doesn't look like there are. Thank you very much. This was extremely interesting. A very, very interesting perspective that you were able to give us from where you are. And then also an extremely interesting discussion here as well. So yes, thank you very much for this fantastic MOOC.
Thank you. Thank you for having me.
Thank you very much.
Thank you.
Have a nice evening.
Bye.
Goodbye.
Thanks. Bye.
Bye.